Now we're ready to prepare the tip. Since this particular tip has a cavity, it will require special cleaning and tinning procedures. First, we'll need to remove any solder from inside the cavity of the heated tip with a non-abrasive fiber tool. It's important never to use a wire brush for any tip cleaning procedure, since the wire will scratch all the way down to the base metal. This would allow oxidation to form on the base metal and severely decrease the useful life of the tip. After cleaning the tip with the fiber tool, the next step is to remove any oxidized solder by shocking the tip on a wet sponge. Now it's time to add solder to the properly cleaned tip. We need to fill up the cavity until there's a small crown of solder that reaches from one side of the tip to the other. Knowing exactly how much solder to add is also learned by experience. We want enough solder to help transfer the heat quickly, but not enough to fall out of the tip during use. The solder will also provide surface tension to lift the component off the lands after reflow. Since the tip has more metal surface area than the lands on the circuit board, the solder will be drawn toward the metal tip, and so will the component. Fork tips can be used to remove a number of different styles of chip components, as long as they fit properly in the cavity. At this point, some of the extremely small chip components won't fit into any of the fork tip sizes that are presently available. To remove these tiny components, you can use a 1/16" chisel tip to simulate the fork tip removal process. We need the tip to be slightly wider than the length of the component so that it reaches almost to the end of both lands. The first step is to flux the component to enhance the heat transfer process. After we clean the tip, we'll apply a little bit more solder than you would normally use to tin the tip. Then we'll place the soldering iron at an angle so that the tip lies flat against the top of the component. We'll use the extra solder on the tip to melt both of the solder joints simultaneously. The flat side of the soldering tip has more surface area than the edge of the tip. This additional surface area will help to create the necessary surface tension to lift and hold the component. This technique will only work for the smallest chip components when properly sized bifurcated tips are not available. Adding the right amount of solder to the tip will also take some experience. If you add too much solder, especially when the components are tightly spaced, you could end up with solder bridging. Now let's cover the removal of chip components that are bonded onto the board prior to the original soldering operation.